Quadratic Equations, Chapter P. A quadratic expression is a polynomial in one variable of second degree. For example, a sub 0 plus a sub 1x plus a sub 2 x squared. Or, listing them in the other order, a sub 2 x squared plus a sub 1x plus a sub 0. Or, a x squared plus bx plus c. As an equation, a x squared plus b x plus c equals 0. I've written the coefficients here and the absolute term in different colors, in a different color, because I want to emphasize those values later. A, B, and C are parametric real numbers, where a does not equal to 0. A does not equal to 0. You should think of A, B, and C as fixed numbers. This is commonly referred to as having been written in standard form. Ax squared plus bx plus c equals 0 is in standard form. For example, 6x squared minus 19x plus 10 equals 0. Here, A, B, and C equal 6 equals minus 19 equals 10. In some application, the equation y equals ax squared plus bx plus c is used, but this will be considered in another semester. Some non-quadratic equations can be dealt with as quadratics. For example, 3x to the sixth plus 2x cubed minus 5 equals 0. Let t equal x cubed. Then this part is plus 2t. And this part is 3t squared. T is equal to x cubed. Then t squared is x cubed squared, and that is x to the sixth. Minus 5 equals 0. This is a quadratic equation now. Another example, e to the 2x minus 3e to the x plus 5 equals 0. Let t equal e to the x. Then, in the equation, e to the x is the t. The rest of it is minus 3t plus 5 equals 0. But here, e to the x equaling t, when t is squared, the result is e to the 2x. And so this part is represented by t squared. Now, t squared minus 3t plus 5 equals 0 is a quadratic equation. The variable of the quadratic can be solved for in several ways. That is, solve for the root of the quadratic. There are several methods available. Number 1 is factoring. If factoring now is possible, then this is the quicker method. Another method is referred to as completing the square. The solution or root of the quadratic can be found by completing the square no matter what the quadratic is that is given. 3, we will use a formula to solve the quadratic. And the formula method always provides a solution for a quadratic equation as well. And the fourth method is by graphing. But we will not use the method of graphing in this chapter. I will show you the method by factoring first. If a and b are linear factors of one variable, this is a theorem, then the product will result in a quadratic equation of one variable. Or a polynomial of degree 2. If a times b equals 0, then it follows that either the A linear factor equals 0, or the B linear factor equals 0. The root for each is easily determined. Thus, the solution to the quadratic is also determined. For example, supposing we have the linear factor 3x minus 2 equals 0, and that 2x minus 5 equals 0. It follows then that 3x minus 2 multiplied by 2x minus 5 multiplied together equals 0. And when expanded, 6x squared minus 19x plus 10 equals 0 is the quadratic. By factoring, and we can conclude that the linear factors 3x minus 2 equals 0, or 2x minus 5 equals 0. Consequently, from this linear equation, x is equal to 2 over 3, or from this equation, x is equal to 5 over 2. Let's verify that these two roots are the solutions to the equation given. First, we'll take x equal to 2/3. The left side of the equation is 6x squared minus 19x plus 10. This is 6 multiplied by 2/3 squared minus 19 times 2/3 plus 10. This amount is 6 times 2 times 2 divided by 3 times 3. We can simplify this to 8 over 3. This amounts to 38 divided by 3, and establishing a common factor in the expression, this is equal to 30 over 3. When you add 8 over 3 to 30 over 3, the amount is positive 38 over 3. Subtract 38 over 3, and the answer is 0, and that verifies. Repeat the procedure with 5 halves. X is equal to 5 halves. Left side equals 6x squared minus 19x plus 10. 6 brackets, 5 over 2 quantity squared minus 19 times 5 over 2 plus 10. Simplifying, 5 over 2 quantity squared multiplied by 6. The amount is 75 over 2. This amounts to 5 times 9, 45, 95 over 2. Establishing a common denominator, which is 2, this amounts to 20 over 2. If you add these fractions, you can see that this 75 and the 20 adds up to 95 over 2. Subtract 95 over 2, and the answer again is 0, and that is equal to the right-hand side of the equation. That establishes the fact that x equals to 5 over 2 is also the root of the quadratic equation. Here is another example. X squared plus 2x minus 3 equals 0. The factors of this trinomial, or of this quadratic, are x plus 3 times x minus 1. If you have either x plus 3 equals 0 or x minus 1 equals 0. Therefore, x equals minus 3 or plus 1. Another example, 6x squared equals x plus 2. You must write this equation as a trinomial, or write this equation in standard form, as we say. In standard form, we would write 6x squared minus x minus 2 equals 0. The factors here are 2x plus 1 and 3x minus 2 equals 0. Therefore, either 2x plus 1 equals 0 or 3x minus 2 equals 0. And finally, from this equation, x equals minus 1/2, and from this equation, x equals positive 2/3. The next method is completing the square. Let a be a number. Then the model of a perfect square in one variable is x plus a quantity squared. Let the letter a be a number. Then the model of a perfect square x plus a quantity squared. When we expand this, the result is x squared 2ax plus a squared. If x squared plus 6x are the first two terms of the quadratic, specifically a trinomial, what would the absolute term or the third term have to be for the quadratic to be a perfect square? Since the middle term in the model is 2ax, then by comparing this to 6x, a must equal to 3. 2 times 3 is 6. 6x, 6x. Consequently, the perfect square, the number 9. x squared plus 6x plus 9. A quicker way to establish the absolute term or the constant term is to memorize these steps.